All right, Mr. Austin here today, and we're going to be taking a look at lesson 4.8, which is the quadratic formula. So this is going to give us yet another way for us to solve a quadratic, or better yet, find where it crosses the x-axis. So let's take a look at a couple vocabulary terms first. Let's start with the quadratic formula itself. The quadratic formula, just a working definition for it, is a formula that gives the solutions of any quadratic equation. So I'll say that again, and I'll just kind of abbreviate what I said. So it's a formula that gives the solutions of any quadratic equation. Okay. Next, the discriminant. Well, the discriminant is interesting. It is a part of the quadratic formula, a small part of it. And basically, I'll be showing you that here in just a moment. When I give you the actual formula for the quadratic formula, I'm going to write the discriminant in a different color and mention that to you. But I want to tell you what the discriminant does. It basically allows you to see how many and what kind of solutions there are in a quadratic equation. Again, it allows you to see how many and what kind of solutions in a quadratic equation. And this can come in handy. All right, so first of all, let's give you the quadratic formula. A lot of you have heard this before, probably even have it memorized, but just in case, I want you to have it copied down. So here it is. It starts out with x equals negative b. Now it's going to be plus or minus, because there's going to be two answers. The square root, I'm going to make this a big square root, of, and here we go, I'm going to put this in a different color because this, what I'm writing right now, is the discriminant. It's b squared minus 4 times a times c. That part of the quadratic formula is the discriminant. So again, it's b squared minus 4ac. All of that over 2a. And that is the quadratic formula. Now, we're going to show you how this works. First example says solve the equation, and then notice it says solve an equation with two real solutions. So we already know we're going to have two real answers here. First things first, in order to be able to find A, B, and C, I have to remember something, that when I wrote out the standard form of an equation, here's what it was, plus bx plus c. ax squared plus bx plus c. This a, b, and c that we're talking about comes from here. And you'll notice I got to get this in standard form before I can find a, b, and c. So that means I got to take the equation they've given us and put it in this format. And that also means, if you look at this, we don't have a y here, which means all we need to really do with this is set it equal to 0. Get everything on one side, which is easy. I can simply subtract x from both sides, or 6 from both sides. So let's rewrite this. When I subtract 6 on both sides, here's what I end up with. X squared plus 7x minus 6 equals 0. And now I have identified A, that's an understood one, B, and C. So off to the side here, let's just jot that down. We know A is 1, B is 7, and C is negative 6. All right, and now that we have that, we're going to now plug this into, if you remember, the quadratic formula. There it is. So you might want to flip back and copy it onto your new page. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's start out with negative b. Well, b is 7, so that's negative 7 plus or minus big square root What goes under it? Well, we call it the discriminant, but it is really b squared, so that's, I always like to put parentheses around that. 7 squared minus 4 times a, which is 1, times c, which is negative 6. All over 2 times a, which again was 1. Okay, let's simplify what we got underneath the square root. Here's how we do this. Start with squaring that out. So let's rewrite negative 7 plus or minus. And then underneath the square root, I've got 7 squared, which is 49. And now I need to multiply these next 3 numbers together. Negative 4 times 1 is negative 4, times negative 6 is positive 24. So that's plus 24 underneath there. Careful with your signs. All over 2. Okay, let's simplify what we got underneath the square root. So we'll come down here and make this negative 7 plus or minus. Big square root of 73 now. All over 2. Now, you may not notice it, but I do. I look at that 73 underneath the square root and I tell myself, that can't be simplified. There's no perfect squares that go into it. Therefore, this problem is done. We just found out what x is. Our 2 answers could be split up. If you want to see these as 2 answers, let me just show you what they are real quick over here. We've got negative 7 plus the square root of 73 all over 2. And we've got negative 7 minus the square root of 73 all over 2. Those are our 2 answers. We could plug it in a calculator and tell you what those are, but they're 2 pretty ugly decimals, so I can leave them in this format. This right here is an acceptable answer. Negative 7 plus or minus the square root of 73 over 2. Okay, let's move on to our next example. Example number 2 says solve an equation with 1 real solution. Interesting, we've got 1 real solution here. Well, what's this going to look like? All right, I've already got it set equal to 0, so I can identify right now in my equation what a, b, and c is. So a is 2. B is negative 8, and C is 8. Okay, so let's go right into the quadratic formula. X equals negative B. Well, remember, B is already negative 8, so we're going to go negative becomes a positive 8, plus or minus big square root of b squared, that's negative a squared, minus 4 times a, which is 2, times c, which is 8. And all of that over 2 times a, which is 2. Okay, let's simplify some of this stuff down. We're going to get 8 plus or minus. Underneath that, 8 squared becomes 64. And then we got negative 4 times 2 times positive 8. That also becomes minus 64. Interesting, we can see what's about to happen underneath that square root. This is all over 4. When that square root, I end up with 8 plus or minus nothing all over 4. So 8 plus 0, well, obviously is just 8, which means all I have is 8 over 4, which means my answer is simply 2. And when we see the example 2 says solve an equation with 1 real solution, yeah, you just found it. There's only one answer to this one. It's x equals 2. All right, let's take a look at example number 3. This one says solve an equation with an imaginary solution. So we've been talking about these imaginary numbers and what happens when you have a negative underneath the square root. Well, let's see one with an imaginary answer. First things first, I want to get this set equal to 0, so I want to rewrite it. So I'm going to put up here negative x squared plus 2x. And all I'm doing is just subtracting 5 from both sides. So minus 5 equals 0. So now I got a set equal to 0. I'm going to put that 1 in there to remember that there's a negative 1 there. The reason why I'm doing that is because we just identified A, B, and C. Okay, so here we go. Let's write it out. A equals negative 1, B equals 2, and C equals negative 5. All right, if we're going to write this in the quadratic formula, let's start with x equals. And again, remember we've got negative b. Well, b is 2, so that's negative 2, plus or minus big square root of b squared, it's 2 squared, minus 4 times a, which is negative 1, times c, which is negative 5, all over 2 times a, which is negative 1. All right, let's see what this simplifies out to. We got negative 2 plus or minus. That first number when I square it is 4. And I got negative 4 times negative 1 times negative 5 gives me negative 20. Right away I notice I'm going to have a negative underneath there, all over negative 2. So we simplify this out, we get negative 2 plus or minus, make sure you know that's a negative, plus or minus, big square root of 4 minus 20, that's negative 16, all over negative 2. All right, so what's this going to look like? Well, I can do a couple of things. First of all, I realize I got a negative underneath the square root, and when I take that out in front of the square root, it becomes I, and that leaves me 16 underneath the square root. So if I do this in 2 steps so you can see everything, I got negative 2 plus or minus I. There's the negative I've now removed from underneath, so now I've got just 16 left under there, all over negative 2. And then notice the square root of 16 we know is 4, so this is really negative 2 plus or minus 4i, all over negative 2. And now I can simply just reduce this. I got negative 2 over negative 2, which is 1, and 4 over negative 2, which gives me our plus or minus 2i, because 4 over 2 is 2. And there are our 2 answers. Again, if you want to see those written out, here's what they look like. It's 1 plus 2i, and 1 minus 2i. 2 complex numbers because we've got imaginary numbers involved in the answers. What does this tell us? This tells us that this parabola does not cross the x-axis. All right, I'm going to leave you with 2 checkpoint problems, and here's how I'm going to handle these. I want you to know that these 2 checkpoint problems, obviously I can use the quadratic formula on them, and what I'd like to do is, I think I'd like to go ahead and just let you try to work these 2 out, but I am going to give you the answers to each one of them. That way as you work them out, you can check your work. So for this first one, you should get a final answer of x equals negative 2 and negative 4. So you can check your work once you've worked that out. And for this last one, a little more complex, you're going to get an answer of 3 plus or minus I square root of 3, which tells you you're going to have a negative underneath there at some point, all over 2. So take a look at those 2 checkpoint problems, work through those, and see if you come up with those 2 answers. All right, moving on to the discriminant. We already told you what the discriminant was. It was the b squared minus 4ac, and you can see it in here. A couple things I want you to know about this. First of all, when b squared minus 4ac, when that quantity underneath the square root is greater than 0, here's what you know. When it's greater than 0, that tells you you have 2 real solutions. And I'm going to abbreviate. 2 real solutions, which means the graph has 2 x-intercepts. When the quantity underneath the square root is equal to 0, so when you work it out and you get 0 underneath there, that means you have 1 real solution. We've already seen both of these things happen, which means we only have 1 intercept. And when you have it less than 0, that means you have 2, but this time they are imaginary solutions. And we just worked one of those out a little bit ago, which means this graph has no x-intercepts. And those are the 3 scenarios for the discriminant. So now if I take a look at how that works, here's a couple examples. It says find the discriminant of the quadratic equation and give the number and the type of solutions it has. So when I'm looking for the discriminant, remember, the discriminant is only that part underneath that square root. So really, I'll write that square root out. It's not going to have a square root, but I wanted to show you where it was at. It's this. It's b squared minus 4ac. That's the only part we're actually looking for. And again, I don't want you to think you have to take the square root of it. So let me go ahead and get rid of that because I just wanted to make sure you know that's what we're looking at. And let's try it with this. First of all, we got to get it set up and equal to 0. Well, it is. Reminder, this is a 1 because now we can identify A, B and C. Since we're using the discriminant, we know it's b squared minus 4ac. So let's plug in for what we know. B, first of all, we know that this is b. So it's going to be 6 squared minus 4 times a, which we know this is a. So that's 4 times 1. Times c, which we know this is c, which is 5. So that tells me that when I put all this together, I'm going to have 36 minus 20, which is an answer that's positive, which tells me that it is greater than 0. If we go back and look at the page before, we notice that when it's greater, we got 2 real solutions and 2 x-intercepts. So over here, we're going to say discriminant, discriminant we just found. The discriminant is 16, and that this has 2 real solutions. And that's what we know about it. Okay, let's look at a different scenario. Again, we're going to identify A, B, and C. And let's use the discriminant. We got b squared, which gives me 6 squared minus 4 times A times C. In this case, we work this out. We're going to get 36 minus 36, which gives me 0. Again, if we go back and see what happens when the discriminant's 0, 1 real solution, 1 x-intercept. So we've got the discriminant of 0, which tells me number of solutions is 1, and they're real. 1 real solution. Last scenario. Again, we're already set equal to 0, so let's identify A, B, and C. Use our discriminant of b squared, so that's 6 squared, minus 4 times A times C. And figure out what this equals. We get 36 minus 4 times 1 times 13 is 52. So that's going to give me negative 16. And again, if I flip back one more time, when I have something that's discriminant less than 0, it's 2 imaginary solutions and no x-intercepts. So for this case, we've got a discriminant of negative 16. Number of solutions, it's 2, but this time they are imaginary. And again, that's important to know because that means that a parabola does not cross the x-axis. All right, so I'm going to leave you again with another checkpoint. I'm going to remind you that I want you to use b squared minus 4ac, which is the discriminant for this. And I'm going to give you this first solution. See if you can work it out and figure it out, but it should be a 1 real. See if that makes sense with your math. And for this one, it should be 2 imaginary. And again, do the math, make sure you get that. Okay, that concludes lesson 4.8 over the quadratic function and the discriminant.